Welcome. In this lesson, we're going to wrap up our primitive data unit by talking about casting and ranges of variables. So let's get started. We've got three learning goals for today. The first is that you can identify and explain implicit casting, that you can explain and use casting to solve problems, and finally, you can explain why data types have limited range of values and use the integer.maxValue and integer.minValue constants. When we're programming, it's fairly common for one type of data to turn into a different type, and when this happens, it's called casting. Sometimes a cast happens automatically, and when that is the case, it's called implicit casting. If you look at the example, I have an int x equal to 7, and in the line below it, I try to save the value 7 in a double variable when I say double y equals x. Now, of course, double y will store a 7. But it doesn't just store a 7, it stores a 7.0 because doubles hold a decimal place. So in this situation, the 7 was implicitly cast to a double, and that 0.0, that decimal point, was added. It turns out that implicit casting is only allowed when data is being added. If the casting causes a data loss, like losing a decimal point, Java won't allow it. And so here's an example. At the top, we have double x equals 7.0, and then below, we try to save that value in an int y when we say int y equals x. Now, theoretically, maybe this could happen. Maybe Java could say, well, we're just going to remove the decimal point, and y will store the value 7. But in actuality, Java throws an error in this case. Java is concerned that perhaps we're losing information unintentionally, and losing a decimal point could potentially result in a wrong answer, so Java simply doesn't allow it. Now, perhaps as the programmer, you want to lose that decimal point. You want to make it go away. And even though Java won't let you implicitly cast and lose data, you can explicitly cast. And the way we do that is we add the type we want in parentheses to force the cast. And you can see that where I say int y equals the int of x. What we're doing is we're taking the int of 7.0, and because we have explicitly stated that we want this, Java will allow that decimal point to be removed, and the data will convert to a 7, which is an int. So we couldn't do this implicitly, but we can explicitly state that we want this, and Java will allow it. Now that we know what implicit and explicit casting is, we need to talk about why we would ever want to use it. So in this first example, we have 30 students and 256 cookies, and we'd like to compute how many cookies each student will get. So we do a division problem, the number of cookies divided by the number of students. Now, since the cookies and students variables are both doubles, the division problem we're doing is 256.0 divided by 30.0. And when we do division with doubles, we are going to get a double answer. And so we'll figure out that we need 8.533 repeating cookies per student. Now, of course, we aren't going to give students half cookies, so sensibly, we're going to save this answer in an integer variable. But when we try to do that, Java is going to throw an error because we're trying to cast our double to an int implicitly. And Java is not going to allow us to do that because it's going to be afraid that we're making a mistake and losing an important part of our answer. As the programmer, we know that we want to lose that decimal point, and we can lose it, but we have to explicitly state it. So we'll still do the 256.0 divided by 30.0, but this time we take that result and we typecast it. And since we've explicitly stated that we want to do that, Java will allow it, and our cookies per student variable will hold an 8. Another place we can use casting is if we want to round it to the nearest integer. And the way we do it is we can add 0.5 to a number and then typecast it to an int. Let's see how it works. So suppose we have the number 2.1, which should round down. The nearest integer would be 2. So we first take the number and we add 0.5 to it. 2.1 plus 2.5 is 2.6, and if we drop the decimal, we get to 2, which is the correctly rounded answer. Let's try this again, but with a number that should round up. So we'll do the number 2.8 plus 0.5. When we combine those two, we get 3.2, and when we typecast 3.2 to an int, we get the correctly rounded answer of 3. We're going to wrap up this lesson with a discussion of ranges of variables. And we don't often think about it, but variables have size limits. They can only hold so much information, and we need to understand those limits in order to use them properly. Variables are always stored in the computer's memory. We don't really think too hard about that. In our minds, this char letter simply equals A, but in the computer, it's actually a series of zeros and ones. Specifically, characters are represented by 8 binary digits, 8 ones and zeros, and a binary digit in computer science is called a bit. With ints, it's the same thing. We think about x as just equaling 13, but in the computer, an int is represented with 32 bits, 32 ones and zeros. So how much can an int hold? Well, we know that an int can store 32 bits, and each bit can be 1 or 0. So there's 2 potential options for our 32 bits. And by doing a little math, if we take 2 options to the 32nd power, we'll get that there's over 4 billion different values an int can hold. Now, in practice, some of those numbers are negative and some are positive, so the actual range of an int is about negative 2 billion to about positive 2 billion. And in Java, you can actually access the minimum and maximum values of an int using the integer.minValue constant and the integer.maxValue constant. Let's try playing around with one of those values. So I've got a system.out.println statement where I take the minimum value and minus 1. Now wait a minute, that should strike us as weird because the minimum value is supposed to be as small as it can get in terms of what an integer can hold, right? That min number is negative 2 billion, etc. So what happens when I subtract 1? Well, if I run this code, here's my output. And if you notice, it actually matches the maximum value. So when I take my minimum value and I subtract 1, it just wraps around to the max value. For the understanding check today, let's keep playing with min value and max value. So let's suppose that I add together the minimum and maximum int values. What do you suppose I'm going to get? Pause the video, and when you're ready, we'll talk about the answer. The answer turns out to be negative 1, and you might have thought it would have been 0, that min and max would have just offset each other, but if you look at the range, the negative number goes 1 further than the positive number, and since the negative number is slightly larger, that's why we get negative 1. Now that you've watched this lesson, you should be able to identify and explain implicit casting, and also use casting to solve problems. Finally, you should be able to explain why data types have a limited range of values and use the integer.maxValue and integer.minValue constants.